Hello everyone, welcome to my channel, and this is Rick Loresto. I'm a circuit builder, and we have guests in my house. My idol, Diode Gone Wild. Hello. We're going to analyze the circuit here. Where is the circuit? Here? Here or here? This one. I think this is the circuit. And the circuit is LDR circuit, light dependent resistor. That is the circuit we're going to analyze. And since this is a circuit built by my friend, I'm going to analyze it with you. Let us see the circuit. This one. This is the circuit diagram. And the objectives of the video is to use LDR in the circuit for controlling the light of the LED. So we're going to control the light of the LED here. We're not going to reverse engineer it. So here also it is a modified circuit, LED circuit. So this is a modified version of LED circuit. This one. So this is the LED circuit. This LED is already a previous circuit. And this one, this is a variable resistor dimmer switch. And it is also a previous circuit. So let us analyze this one. This LDR circuit. And what's the problem here? It's this very simple circuit. You're making funny at me. You're joking at me, huh? It's very simple circuit. I don't build this kind of circuit. It is for a grade schooler circuit. But since I'm guest here, let's analyze the circuit here. It seems that just like here, this is the mother circuit. You just put a LDR here, and then it becomes light dependent resistor LDR circuit. And this is a modified circuit now, just like here. You're putting a resistor dimmer switch here. You're just placing a variable resistor. So let us check the circuit. What's the problem here? Very simple. I don't build this kind of circuit. This is very simple. Let us trace the current flow here. Closing the switch. Current flows to the resistor, LED, and the LDR. So that is the current flow here. So what's the problem here? It seems that our circuit is functioning. Oh, did you see that? That is the of LDR here. What is this? Given voltage rating of the LED 2 volts, current rating 0.02, and this dark resistance of the LDR, what is this? 1 mega ohms. So let us explain that dark resistance. If the resistance of the LDR is equal to 1 mega ohms, that is dark resistance. How can I demonstrate that? Let me see. We have some ball pen here. A pen. Okay. And we put a cup here. LED turns off. Okay. Put a cup. LED turns off. LED turns on. LED turns up. It means the LDR is dependent on the light, the resistance. So when I put the cap here, it has a 1 mega ohm resistance. That is the dark resistance. They call it a dark resistance, 1 mega ohms. That's why LED turns off. And you know that the voltage rating and the current rating of the LED is 0.02 ampere to turn on the LED. Since it is not turning on, it means the current flows here is not 0.02 anymore. That is the dark resistance. And having this cap put in the LDR, it makes this LDR to have a dark resistance of 1 mega ohms. That is given in the data sheet of the LDR. So that is the way of controlling the LED lights, by controlling the LDR, or put it in the dark. When there's no light, there's no current flows, and the LDR is having this dark resistance. So we are using here Ohm's law. Since Ohm's law here is very favorite, and we have here resistance law. Let's find the total resistance in the circuit and the total current in the circuit. Why? Because LED here is not lighting. So let us find the resistance. Using Ohm's law, voltage supply is equal to voltage total, 12 volts. Of course, 12 volts, very simple. So, total resistance is now in series because we're having this dark resistance. When you're putting the cap here, it has a resistance of 1 mega ohms. So, law of resistance in series, just add it. We have here 1 kilo ohms equal to 1,000 ohms. 1 mega ohms is 1 million ohms. Add, we have 1,000,000 ohms. And using the Ohm's law, voltage is equal to current times resistance. We get a total current of substitution here. 12 volts, 1,000 are total. We get now a total current of 0.0001198 ampere. So it means the current flows here now is this. And this is not enough to turn on the LED because the current rating of LED to turn on is 0.02 ampere or 20 milliamperes. 0.02. But here we have 0.0000. Almost shorted, I think, or still there is a little light here, or I think it's not totally off because there's still a current flowing here. See, that is the effect of putting the LDR in a cup or having a dark resistance of 1 mega ohms. So in here we have the symbol for LDR, just like a resistor with the oval in circle enclosed. And this is an arrow here indicating that the resistance of the LDR is dependent on the light source. So when there's light, the resistance is varying. When there's no light, totally, LDR is 1 mega ohms resistance. So when I remove the cap here, it varies. Just like here, in our resistor variable dimmer. It means here, it is also a variable resistor. But the one controlling the variable resistance is the light. Because we have light here. If we put out the light, or close it. Oh man, close it in the cup like this. It's just like you are turning the knob of variable resistor like this. And the variable resistor depends on the tuning knob of the radio. See? Just like that. By varying the resistance here, you can vary the resistance here. That is the dark resistance. So it means it has having 1 mega ohms dark resistance. And if we're going to remove the cup slowly, it's see? That is the basic operation of an LDR here. We got a layout here. So that's very simple. We're almost finished here. It is just like the LDR. It's the same as this variable resistor. You just varying the light. Here, oh. See? And the resistance here is 1 mega ohms, the dark resistance. It means that LDR is in the dark. There's no more light, 1 mega ohms. If you're going to decrease the value of the resistance, just expose it to the light. Just like that. See, it's very simple. Very simple project. Why don't you just buy it in the Google or in the YouTube? You are wasting your time building this project, my friend. But I'm guess here. It's still a circuit. Since you're a circuit builder, you build a circuit here. And I'm going to explain it. See? Almost the same here. This one. It's just putting LDR here, it becomes LDR circuit. This LED circuit. So, that is we achieve these objectives here. We are controlling the LED light by varying the resistance of the LDR by put it in the dark. Where is my cup? Oh. This one. And decreasing the resistance of 1 mega ohms. If maybe this one is 100 mega ohms, 100 ohms or 100 kilo ohms. We don't know. But it's the one with varying the resistance. This one is varying the resistance by tuning the knob, putting more resistance. And we already have the calculation here in our previous video. So that is very simple. You are always kidding me, my friend. I'm not getting sweat here. Because very simple circuit. We calculated the values of current here. And that's it. Very simple. See? Even the kids can do this. Can understand this. So, thank you for watching the video. And bye-bye.